Welcome to Volume 2 of the Enterprise DevOps and Platform Engineering Study course. This 20-minute lesson covers Git, GitHub and Jenkins, Enterprise Source Control, CI, CD design, Jenkins pipelines, and production. The goal is to build an interview-ready mental model, connect architecture with implementation, and show how a senior engineer diagnoses production failures. Take notes on the control flow, security boundary, failure modes, and validation commands in every section. The video is a guided overview of the complete handbook, so use the detailed document and labs for deeper practice after watching. Enterprise CI CD Architect. The module on Enterprise CI CD architecture and design principles establishes the following ideas. A mature CI CD platform is a product, not a collection of scripts. It needs a service owner, an availability target, a security model, a support model, and a control change lifecycle. The pipeline should provide fast feedback while preserving reproducibility, traceability, and separation of duty. Figure 1 Enterprise GitHub and Jenkins CI CD HLD continuous integration validates source and produces an immutable artifact. Continuous delivery changes a version-controlled deployment declaration. A reconciler such as Argo CD performs cluster convergence. This separation reduces the privileges required by Jenkins and creates a complete Git audit trail for production changes. CI responsibilities: compile, test, scan, package. CD responsibilities: promote approved artifact references, reconcile desired state, verify. Control objective: Jenkins should not require unrestricted cluster admin credentials for normal application delivery. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Git object, model, and commit lifecycle. The module on high-level design and low-level design establishes the following ideas. Define system boundaries, trust zones, users, external dependencies, traffic paths, and document critical non-functional requirements, recovery time objective, recovery point objective, concurrency, retention. Identify failure domains such as GitHub availability, DNS, certificate expiry, Jenkins controller, agent cloud, registry and artifact, repository and folder structure, naming standards, labels, credentials ID and plugin and network ports, TLS termination, reverse proxy headers, storage paths, backup exclusions, and log destination. Pipeline stage contracts, timeout values, retry policy, artifact retention, promotion rules, and post-build. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management, and evidence. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Branching, merging, and release strategy. The module on Git working tree, index, and commit lifecycle establishes the following ideas. The working tree is the checked-out file system. The index is a proposed tree for the next commit. The commit records the tree generated from the index. Many Git problems become simple when you identify which of these three states contains the desired version. The module on branching strategies and release management establishes the following ideas. Figure 3 trunk-based pull request and release flow keep main releasable. Use short-lived branches, integrate frequently, and placing complete behavior behind feature flags. Long-running branches increase integration risk and make emergency fixes difficult to propagate consistently. Use annotated and signed tags for releases when assurance is required. Use semantic versioning only when the compatibility model is understood. Do not mechanically increment versions. Record artifact digest, source commit, pipeline run, dependency manifest, and from a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. GitHub governance and pull requests. The module on Git security, signing, and supply chain controls establishes the following ideas. Protect default and release branches from direct pushes. Require verified status checks and current approvals before merge. Use signed commits or signed tags where the threat model justifies it. Scan for secrets before commit and continuously in the central repository. Pin third-party automation by immutable revision where practical. Remove credentials from history and rotate them. History rewriting alone does not invalidate exposed secrets. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management, and in an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on pull requests, reviews, and CODEOWNERS establishes the following ideas. The author provides purpose, risk, testing evidence, and rollback consideration. Automated checks validate formatting, tests, policy, security, and reviewers assess correctness, operability, maintainability. CODEOWNERS ensures specialized review for sensitive paths. The merge strategy produces predictable history and release metadata. The module on GitHub webhooks, apps, APIs, and status checks establishes the following ideas. Figure 4. Sign GitHub webhook delivery. Webhooks are entrusted inbound network requests until their signature, event type, delivery identifier, and freshness are validated. The receiver must use the raw request body for HMSC comparison and a constant time comparison function. Webhook signature verification return quickly and process events asynchronously to avoid retries caused by receiver latency. Persist the delivery ID and make processing idempotent because delivery can occur more than once. Limit accepted event types and repository identity. Do not log secrets or full payloads containing sensitive metadata. Monitor delivery failures from both GitHub and the receiving platform. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Jenkins controller and agent architect. The module on Jenkins platform architecture establishes the following ideas. Figure 5 Jenkins controller and ephemeral agent architecture. The controller maintains job configuration, schedules work, stores pipeline state, serves the UI and coordinates. Build execution should be moved away from the controller. A controller with executors enabled becomes a larger attack surface and a resource contention risk. The module on Jenkins installation, configuration and reverse proxy establishes the following. Run Jenkins under a dedicated operating system identity. Pin and test controller Java compatibility before upgrades. Place Jenkins HOM on reliable storage with sufficient node capacity and backup support. Terminate TLS at a hardened ingress or reverse proxy. Manage configuration through JCASC, code and controlled credentials rather than ad hoc UI changes. Disable anonymous access unless explicitly required and risk Nginx reverse proxy example illustrative system unit. The module on Jenkins controller agent engineering establishes the following ideas. Agent design determines pipeline scalability and blasts use labels to express capabilities, not team names. An agent image should be reproducible, patched, and versioned. It should not carry long-lived cloud credentials. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on Jenkins pipeline fundamentals establishes the following ideas. Figure 6 pipeline, stage, and gate internals. A Jenkins pipeline is a durable workflow whose definition is normally stored beside the application source. The pipeline should declare resource requirements, timeouts, retention, and stages should have clearer contracts and produce machine-readable evidence. The module Unscripted Pipeline and Groovy Fundamentals establishes the following ideas. Scripted pipeline provides full Groovy control and is useful for dynamic workflows, but it can become difficult to govern. Shared libraries should isolate complex logic while application Jenkins files remain declarative and readable. Scripted pipeline pattern do not use Groovy string interpolation for secrets passed to shell steps. Keep controller-side Groovy computation small. Use external tools for large JSON, YML, or file operations. Treat shared library changes as production platform changes with compatibility testing and versioning. The module on Jenkins shared libraries establishes the following ideas. Figure 7 shared library loading and policy model shared libraries reduce duplication and encode platform conventions. They are most successful when they provide stable, product-like interfaces instead of hiding every detail behind a single unchangeable pipeline vars or standard pipeline.groovy src or org or example or pipeline or getutils.groovy. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Shared libraries and configuration as code. The module on credentials, identity, and secret management establishes the following idea. Figure 8 identity and secret flow credentials should be referenced by stable ID, injected only into the smallest necessary scope and replaced with short-lived identity wherever possible. Masking reduces accidental exposure but is not a security boundary against malicious build code. The module on plugin governance, upgrades, and security establishes the following ideas. Plugins extend the controller process and therefore become part of the platform attack surface and compatibility matrix. Reduce plugin count. Remove abandoned plugins and test upgrades in a representative non-production controller. Export the current plugin list and configuration. Read security advisories and dependency. Backup Jenkins HOME and verify rollback capability. Clone production configuration into a test controller. Upgrade Jenkins core and plugins according to the supported dependency sequence. Run representative pipelines, authentication, agents, roll out with a maintenance plan and monitor error rate, queue behavior, and controller resources. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Credentials, high availability, and the module on artifact management, caching, and fingerprints establishes the following ideas. Jenkins should orchestrate artifact publication, not become the long-term artifact repository. Store binaries and container images in systems designed for immutability, replication, access control, and life. Use checksums and immutable coordinates. Record source commit and build URL as artifact metadata. Separate release artifacts from disposable test output. Do not cache credentials or workspace directories containing secrets. The module on quality, security, and deployment integrations establishes the following idea. Integrations should fail predictably and expose clear evidence. A quality gate should report the exact rule and link to the analysis. Security tools should produce machine-readable reports and an exception workflow with expiry and ownership. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Production troubleshooting and interview focus. The module on high availability, backup, and disaster recovery establishes the following ideas. Figure 9 Jenkins High Availability and Disaster Recovery Reference Architecture. Traditional Jenkins controller high availability is normally implemented as rapid recovery rather than two controllers concurrently writing the same Jenkins HOME. A tested warm standby with controlled storage attachment and DNS failover is safer than unsupported active file system access. Declare incident and stop writes to the failed controller or storage. Provision the replacement controller at a known compatible core and plugin set. Restore Jenkins HOME with ownership, permissions, and secret material intact. Attach agents or verify dynamic cloud provisioning. Validate authentication. Representative pipeline. Move DNS or load balancer traffic and monitor. Document data loss window and follow-up actions. The module on monitoring, logging, and capacity management establishes the following ideas. Capacity management must distinguish controller load from agent workload. Controller health is affected by queue listeners, pipeline state serialization, SCM indexing, plugin behavior, UI or PIUs, and log retention. Build CPU and memory should be consumed on agents. Forward logs to centralized storage. Alert on controller unavailable. Queue age. Agent provisioning failures. Disk or node pressure and backup failure. Create synthetic tests that trigger a small pipeline and verify artifact publication. Track plugin and configuration changes as events alongside metrics. The module on production troubleshooting runbook establishes the following ideas. Figure 10 CI. CD troubleshooting decision flow troubleshooting starts by identifying the first failed boundary. Avoid changing multiple components at once. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. You have completed the guided overview of Volume 2, GitHub and Jenkins. The next step is practical repetition. Recreate the architecture without looking at the handbook, implement the supplied labs, inject at least 3 failures, and document symptoms, evidence, root cause, mitigation, and prevention. For interview preparation, answer each scenario aloud using a structured sequence, clarify impact, establish scope, check recent changes, collect evidence, form and test hypotheses, mitigate safely, validate. Senior level performance is demonstrated not by memorizing commands, but by making reliable decisions under uncertainty.